This is good for the video recording so far, isn't it? Bit of chatter. So today we're going to start with looking at multiplying and dividing surds. Honestly, don't get too caught up in all of this work. It's going to feel more complicated to explain than it is to do. Don't get blinkered and go, oh, no, I'm stuffed. You pretty much need to just practice it, and you'll feel really slow at the start potentially, but then you'll build a little bit of fluency with it, and then the more you practice, the faster you'll be, and then you'll be good to go. So I've got a few examples to work through though, just so that you're conscious of everything. So this first example is pretty straightforward, but after that, it does pick up pace pretty quickly after that. So, just thanks for those who are starting to write down what you can see on the board, and I do want you to do that. Don't worry, I'm going to flick over to just a blank screen for a second, just to do a bit of background information, and then I'll come back to it. So just bear with me. Do you remember this index law? If I multiply two things together and raise it to the power, some sort of power, then I can say that's a to the power of n times b to the power of n. So two separate bases sharing the same power. Yeah? So if I had, I could also work the other way around. If I had x to the power of 3 multiplied by y to the power of 3, I could say that's x times y to the power of 3. Is that okay? So if I had 2 cubed, which is 8, and 3 cubed, which is, man, can I change that? 2 squared multiplied by 3 squared. What's 2 squared? Yeah. What's 3 squared? 9. What's 4 times 9? What is it? Yeah. If I use the rule, though, just to show you that it does work with numbers as well, I would get 6 squared. And what's 6 squared? Right, it's the same answer. If it was a different answer, then the universe would explode, and that's always awkward for everyone involved. So luckily it is the same answer. So 2 squared times 3 squared is the same as 6 squared. So it does work with numbers. Good so far? Well, my point is, the reason why I'm going through this first is that I could use the same logic with a fraction index. So if I went x to the power of a half multiplied by y to the power of a half, that's just xy to the power of a half. Happy with that? Again, using a common sense logic kind of thing. If I went 4 to the power of a half multiplied by 9 to the power of a half, well, what does 4 to the power of half mean? Can you remember? Good. So that's root 4 or square root 4, and 9 to the power of a half would be square root of 9, good, which is equal to 6. We okay with that? Okay, I've run out of room here, so I'm going to have to erase. Alternatively, we could use that law up the top there, which would say that's 4 times 9 to the power of a half, which is 36 to the power of a half, which is the square root of 36, which is 6, same answer. You see what I mean? So surds and indices are a reflection of each other. Surds, or square roots, specifically, we're using surds, but square roots are just an index where the power is a half. It's really important that you get that. So the logic that you would use for indices also works for this as well. Also works for square roots. So there we go. Back to the start. That was my rewind noise, by the way, in case you're wondering. I hadn't just had a mini stroke. It was a rewind noise. So when you look at the instruction there, I hope it kind of makes sense. What I've said here is multiply the rational part. Now that's the best, that's the shortest way I could say the bit outside the square root symbol. So if you need to put a little star there and write the bit outside the square root symbol, please do that. I just didn't because I wanted the notes to be succinct. So I'll put my pointer next to the number, which is rational here, 2, and this bit here, 5. These are the rational parts. So it says multiply the rational part, multiply the surds. So this is root 3 and root 6. So using the same logic I just showed you, root 3 times root 6 would be what? You got it? Did everyone hear that? Great. So let me do this in total for you now. So it would be 2 times 5 is 10. Got that? The two rational numbers multiplied together. 2 times 5 equals 10. And then root 3 times root 6 is root 18. Yeah, you're ahead of me. Not quite 20, but you get something like that. Would anyone like to ask me a specific question about what I've just done? I'm not finished, but we're nearly there. Always, always, always then, I'll move on. Always, always, always. When you get a final answer, you then, and I'll zoom out so you can see both on all screens at once now, you simplify the surd if possible. It's not always possible, but when we look at root 18, what we do, just like we did on Tuesday, is we're looking for we're looking for square numbers that will go into 18. So you can do it just by gut feeling. 9 goes into 18, I know that. Or you can be systematic and you can go 1 squared. Well, 1 goes into 18, but who cares? 2 squared is 4. 4 doesn't go into 18. 3 squared is 9. 9 does go into 18. So you can be systematic or intuitive depending on your confidence with your factor work. So we would just do our usual steps. Again, I'll do it longhand. You could do it in one step if you're happy to. So I will go, that's 10 multiplied by root 9 times root 2, which is 10 times 3 times root 2, which is 30 root 2. Alrighty, so it really is a process, guys. I saw more than one person getting confused with simplifying last time. It's really common. So I'm talking about more than one person in this class, and over my career as a mathematician, I have seen tens, maybe hundreds of students do the same thing. People are able to split this, but for some reason in their head, they then go 2 root 9 instead of 9 root 3 root 2, or they go 9 root 2. So they split it but don't square root it. So to fix that, you just need to be really systematic with it until it's intuitively right for you. So you can do it in one step eventually, but before then, just go split it to 2 square roots. The square root that I can simplify, I simplify, and then I mash it all together. So be really systematic until you're intuitive with it. Okay, I cannot emphasize that enough. It's okay that you don't get it yet, but your key to getting it is being systematic with your working out. Follow the same steps. Be rigorous with following the same steps. You will get there. I've just realized I'm probably making everything muffled for you, but also for the recording with that on, so I'll take it off. Anyone got any questions over that before I move on to the harder example? It's quite hard, comparatively, I mean. Okay, so you can see I've got my advice there. Is that too small down the back there? Is that okay? Or it's not okay? Oh, sorry, it is okay. Yeah, cool. So example 2, root 3 plus 2, root 4 plus 1. We follow the usual expansion rules. Whether you use the box method or the chicken beak method or just by observation, you do the same method. And effectively, it's multiply this by each thing here, multiply this by each thing here. Okay? So I will use the box method because it's the most visual. Personally, I would probably do it in my head, sort of chicken beak style in the head. But this is just for the notes, really. So box method, as we know, we put the first bracketed pair on one side, doesn't matter which side, but I tend to put it here, root 3 plus 2. We put the other expression on the other side and we fill in the boxes. Root 4 times root 3, we just did multiplication a second ago. What will that be? Yeah, root 12. Some of you might simplify that in your head at some point and go straight to 2 root 3. That's good as well, but you don't have to. 2 times root 4 is just 2 root 4. 2 times 1, sorry, root 3 times 1 is root 3, and 2 times 1 is 2. So there's my 4 components. And note that at the moment, we don't have any... Did I do root 4 plus 1? That's dumb, isn't it? Why is that a dumb example? So dumb. Come on, you can tell me. Why is root 4 a dumb example? Say a bit louder, thanks, Logan. It's equal to 2. So if I was doing this for realsies, I would have just gone, oh, root 4 is 2, 2 plus 1 is 3, and then 3 multiplied by this. Much easier way of doing it. So what I'm about to do is a pretty dumb example. I'm going to leave it because I don't want to stuff up your notes, but if you feel free to write a note and say, this is a dumb example by Richard. Okay, let's pretend though. Let's pretend that I didn't see that. So if I write it all out, it would be root 12 plus 2 root 4 plus root 3 plus 2. So you can sort of see there's no like terms to add together yet. Root 12 is different from root 4. It's different from root 3. So again, to remind you what we did on Tuesday, we can't add square roots together that are different under the root sign. But what we should always try and do is we should try and simplify each of our surds to see if we get somewhere. In this instance, we do. Root 12 is root 4 times root 3. So I've done that first. You see what I've done there? I just wrote the rest of the problem out as it stands. All I've done is I'm circling it now. I've just adjusted this bit. And again, I encourage you to do this in your head if you can, so that you're not wasting too much time. Oh, maybe I should have done this as well. Okay, 2 root 4 is just 2 times 2. That's 4. And now I will collect the like terms together. So I've got a 2 root 3 and a root 3. So that's 3 root 3. And I've got 4 plus 2 is 6. So that is a massively long way to do the problem that I started with. But nevertheless, it does show you how to do, an expansion with square roots in it. Can I just point out that if you look at this, 3 root 3 plus 6, I started with root 3 plus 2. And remember what I said? This is basically 3 here, because root 4 is 2, 2 plus 1 is 3. So this is 3. 3 times root 3 is 3 root 3. 3 times 2 is 6. So it does work out, and a lot simpler if I'd realised. I should have said root 5 or something like that. It was just, a brain fade moment when I was figuring out the example. Okay, a dumb example aside, does anyone have any questions about example 2? I'm just trying to give you a bunch of different examples so that you can effectively just get to work without and have examples to look back on. What I'm noticing, by the way, is that these summary notes are designed, number one, so that you've got an opportunity to ask me questions as we're doing the examples, but also it gives the examples are there so that you can copy the steps when you're doing your own work. What I'm noticing is that people are making pretty fundamental mistakes in their own work, and I get the feeling that they haven't looked at their summary book and tried to copy the steps themselves first. So that's what those examples are there for, to copy the process down so until you get it right. Okay, example 3. It's another expansion, but in this time, it's a perfect square expansion. So I'll just remind you of the perfect square expansion. If I have a plus b all squared, I square the first. I double the product, so 2 times a times b, and then I square the second. That's the rule for expanding a perfect square. So we use that exact same logic here, but a in this case is what? Is root 3. B is simply 2. Okay, so the next step would be, and I tend to leave things in bracketed form to start with. So I would go root 3 squared, excuse me, root 3 squared plus 2 times a times b. So 2 times root 3 times 2 plus b squared, which is 2. So again, a squared, 2ab, 2ab, b squared. Remember, 2ab means 2 times a times b. I've been yelling at this side of the class for long enough. I'll go to this side instead. I'll yell at you guys instead. Okay, before I complete that, is that okay so far? This is a straight usage of the rule. If that looks like hieroglyphics to you, that tells me you need to go back and practice expanding squares and stuff like that, perfect squares. Okay, next line. Root 3 squared is root 3 times root 3. And I think we've covered this in the first lesson. If I square a square root, what do I end up with? The original number, right? So root 3 squared is just 3. This one here is like a multiplication of a surd, except that I've just got the one surd there. So it's 2 times 2, which is 4, and then we've got the root 3 at the end. So this middle term is 4 root 3, and then 2 squared is 4. Now we collect like terms. We've got 2 rational numbers here with no surd part. So 3 and 4 is 7. And then we've got a surd part here, 4 root 3. So it just needs to be tacked on to the end. So it's 7 plus 4 root 3. Questions before I move on? You know what? The video's been going for a bit long, so I might even pause and just give you a bit of time to do some practice on these and then go on to division in a sec. Before I do that, any questions about this? Particularly going from here to here, if you're not too sure. Okay, I've got a question for you then, since you refused to ask me questions. What maths fact, I nearly spoke like an American then, a math fact. What math fact prevents me from having a final line? Why can't I do this? What maths fact, so I can't do this? 7 plus 4 is? Yeah, I can't do that. I can't say which equals 11 root 3. I cannot do that. That is wrong. What maths fact tells me I can't do that? Starts with B and ends in S. May. Yep, well done. Did everyone hear that? You're right, so say it loud and say it proud. Was that louder? Feel quieter. Once more, go, you can do it. Oh man, is that the loudest you can get? Okay, thank you, appreciate it though. Sorry to give you a hard time. Yeah, so BODMAS, because BODMAS says I cannot do an addition before a multiplication. I mean, it says more than that, but in this context, I cannot do an addition before a multiplication. There is a multiplication between the 4 and the root 3. So I can't go 7 plus 4 is 11 because of the root 3. Because I can't multiply 4 and root 3 together and get a single number, because, well, not and keep it exact. I'm stuck with this being as simple as I can get. So I cannot do that. If you think that's something that you might forget, you might want to put a note on your summary, say note does not equal 11 root 3, bracket BODMAS. Okay? I'm going to erase that. Alrighty. Work from your worksheet for the next 10 minutes. It doesn't matter if you don't finish all the multiplications in that 10 minutes, but I'll just give you a 10-minute thinking break, and then we'll get to division. So if you look at your sheet set over the page, it says multiplication and division. There's a bunch of multiplications. Again, you can just work down one side of the questions if you want to, but don't get to the, I mean, you can try and figure out the divisions for yourself if you want to. It's not massively revelatory what I need to tell you, but feel free to stop at the end of the multiplications and work on the other side. So I'll pause the video and then I'll come back for division.